All right. Advent of Code Day 10. Hopefully my mic sounds better, actually being a mono channel instead of just on the left. So, yeah, we'll see how this goes, assuming I upload this. Anyway, we're about to start, so here we go. Okay. Be helpful if I remember my own API. Um, or uh, What did I do wrong? Right. Of course. Um, one step. Okay. Why is that 15? That should be way higher. What am I doing? Yeah. Not that that should change anything. Yeah. Okay. Fine. Right. Then I can do this. 1 and 1, that's not correct. Um, yeah, the bottom should have a score of 2. Wait, that's how? Well, that was stupid. Okay. Yeah. Yeah, that was so bad. Oh, okay, so that's fine. Um, Yeah, I mean, basically just that, right? No. Oh, because I need to get rid of that. And now you don't actually finish, do you? Is the problem. Oh, maybe you do. Okay. Well, that was very awful. Um, yuck. That was supposed to be an easy problem. Anyway, I'm gonna try to be better than I was yesterday and actually talk about my solution. Yeah, so we've got the grid here, and we've got trailheads at 0. We need to get to the end. All of this should be relatively easy. Just take our steps one by one and count how many times we find a position 9. So all of that actually I had mostly implemented pretty quickly. I have this nice grid library to parse grids like this. I have in that grid library a way to just get the chords by value so that I don't even have to write the loop to get the starts. I thought actually initially that we were going to have to do some like optimization in terms of pathfinding. So I was starting to use my graph library, which turned out to be just a straight waste of time. Didn't need that at all. Uh, but yeah, after we have the starts, we just need to score each trailhead, which I had mostly implemented correctly. I started at a given coordinate. I recursively walked through to find all the neighbors and from a given position, say the 0, got all its orthogonal neighbors and checked to see, hey, are we making a step of 1 from V to V2? All well and good. And then recursively go and check the next neighbors. Except I just did a silly yield. Just yield impl instead of yield from, so I was returning iterators as opposed to returning the contents from the iterator. Really silly mistake. That cost me, I don't even know how much time. I guess one advantage of recording this is I will be able to find how much time and probably be very sad. But yeah, I mean, once we get all the end coordinates, throw them into a set because we're just counting how many trail ends we can get to, and that's our score. Sum it up. We've got our answer for part 1. Then part 2 is just we count the individual paths. So it's actually extremely similar. Really, it's this identical solution. Just instead of a set here, just we can turn this into a list because well, a list and get rid of this scene set optimization. I was doing this kind of expecting that the grid was going to be big enough that would have so many diverging paths it would be some sort of exponential deal. Um, Looking at the size of this grid and thinking about it, since we're going 0 to 9, it actually makes sense that it doesn't need that optimization. So yeah, I had to take that out in part 2 and just take a list and just naturally, as this walks through, it's going to count all the paths. So really very, very easy transition from part 1 to part 2. Um, just relies on you getting part 1 done correctly. So yeah, I guess that makes 2 days that I'm recording my solution and then am really not happy with my performance, but that's how it goes. So hopefully I'll do better tomorrow, but we will see. Yeah, that's all I got.